The twin paradox is the most famous of all paradoxes in the special theory of relativity. But before we get into it, let me just stress the most important point. There are no paradoxes, as I said earlier, in special relativity. If there were, the theory would collapse. There are, however, situations where it seems like there's a paradox. It seems like we have two perspectives that we can't somehow meld together into a coherent story. But that generally means we have to think the situation through with detail. Think it through with our understanding of the essential physics. And when we do that, all paradoxes fall to the side. The same will happen here. Okay, let's set it up. The paradox, or the seeming paradox, will involve a couple of characters. They are twins, George and Gracie. And the scenario is one that may have occurred to you in our earlier discussion of time dilation and space travel, because we are going to imagine, in this case, that Gracie goes into a spaceship. She travels out into space. We're going to have her go pretty fast. She's going to turn around and come back. Here is the issue. From George's perspective, stay at home, George, on Earth. Looking at Gracie, from his perspective, he knows how time works in special relativity. He says that her clock must be running slow, so that when she comes back, he will say that he will be older. Not as much time will have elapsed on her slow-moving clock compared to him. Gracie, however, she looks back at George and she says to herself, look, I understand special relativity too, and it's George from my perspective that's moving. I'm stationary, and therefore it's his clock that's ticking off time slowly. So when I return, it should be the case that I, Gracie, am older, because less time will have elapsed on George's clock. That is the issue. Let's see that in visual form. So here is the question. There is George, first character, and let's bring in his twin. These are fraternal twins. Gracie, she gets into her spaceship, and we're going to send her off into space. So let's do that. And let's say she's going fast, so there really will be some kind of significant time dilation going on here. She goes off into space. She's going to reach some point that we will call P, the turnaround point, and she will then come back. Okay, so then the question that we are faced is, when these two guys compare the amount of time that has elapsed according to each, will it be the case that George is older than Gracie? Will his clock have ticked off more time? Will it be the case, on the other hand, that it is Gracie that is older? Will it be that more time has ticked off on her clock? Or you could even imagine a resolution that puts these two together. Maybe it's the case that each of them will have aged, each will be the same age as the other when they return. That is the question. We want to figure out which of those three scenarios is correct to resolve this seeming paradox that each says that the other's clock must be ticking slowly. Each therefore says that they should be older. Okay, so I'm going to offer you some resolution to this paradox. The deep question is, who is right? Which of these scenarios is correct? Now, you might guess that they are both right, because that has been oftentimes what we have encountered so far in special relativity. Each perspective is right, and you just have to reconcile them with your understanding of how special relativity works. So that's a natural guess, but that guess will not fly in this case. That will not work, because at the end of the journey, right, George and Gracie are together, right? So they can face one another. They can be standing right next to each other. In fact, they can even go into the same frame of reference. And there can no longer be any mismatch in their observations at that point. One cannot look at the other and say that you are older, and the other looks at the other person and says you are older. That's a contradiction. That's a paradox. That can't happen. So we cannot rely upon the kind of resolution that we have found earlier. Somebody here is right, somebody here is wrong. How do we figure out which? Well, I am going to give you the answer. It is Gracie who turns out to be younger. George turns out to be older. And I'm going to give you 3 explanations for that. Let me start with explanation number 1, which is a simple explanation that really cuts to the heart of the matter. Where does the contradiction come from? Where does the apparent paradox come from? It comes from George saying that he can be viewed as at rest, Gracie moving, therefore her clock ticks off time slowly, and, of course, Gracie can say, I am stationary, and it's George who's moving, and therefore I can claim that it's his clock that is ticking off time more slowly. Is that valid in this situation? Well, remember, the only time that you can claim to be at rest and the rest of the world is moving by you is if you are going at constant velocity, constant speed in a fixed direction. That is manifestly not true in this case for Gracie. Gracie going out into space and then coming back. She has to turn around. And when she turns around, she has to accelerate. She slows down and then she speeds back up to get back to George on Earth. She feels that acceleration. She knows that she is moving. She is no longer moving at constant velocity. She is no longer justified in saying that she is at rest and the rest of the world is moving by her. So her perspective, her reasoning is negated by the fact that she is accelerating. She's not in an inertial frame of reference throughout the whole version of this journey, and therefore we cannot trust her conclusion. George, on the other hand, is in an inertial frame. He is at rest on Earth's surface. He does not move, subject to the issues of whether Earth's surface is an inertial frame, but those are the complexities that we are not worrying about for the discussion we are having. George's perspective, therefore, is valid. He is constant velocity throughout this entire journey. His conclusions are unassailable. They are absolutely correct, and he says that Gracie's clock is ticking off time more slowly, and therefore, when she returns, he will be older. Period. End of story. That is the resolution, or I should say a resolution, of the twin paradox. We will come to other explanations as we proceed further with this deep scenario that lets us really sink our fingers into a lot of the details that we have been developing. But as a first pass to this scenario, that is the explanation. Gracie is accelerating for part of the journey. Her perspective, therefore, cannot be taken into account. She cannot say she's at rest. George is the only one who can say that, and his conclusion that he will be older is correct.